Here we have AP calculus AB problem. Okay, let's go with the information. Find the indefinite integral by u substitution. Hint, let u be the denominator of the integrand. Remember to use absolute values where appropriate. Use c for the constant of integration. So the question clearly says that we have to find the result of this indefinite integral by u substitution, and also there is an hint, that is we have to take the new variable u for the denominator of the integrand, that is square root of x -2. Okay, let me start with u substitution. That is, I'm going to assign a new variable for the denominator of the integrand, that is square root of x -2. So let me write the stuff over here. That is, let u equals to square root of x -2. Since I have assigned new variable u over here, I have to get the complete integration in terms of the new variable u. So that is, I have to get everything in terms of u, and even for this dx, I must be getting du. So if I want to get du, what should I do with this u? For that, I have to find derivative of this u. Since we have the original integration with respect to the variable x, now we have to find derivative on both sides of this equation with respect to x. When I find derivative of this u with respect to x, I am getting du over dx. Okay, now we have to get the derivative of this square root of x, so that we can do it separately. Okay, now let me consider the square root of derivative of square root of x, that is square root of x prime. So before we find derivative, we have to write the square root as an exponent. Then I'm getting x to the power of 1/2. Okay, now to get the derivative of this x to the power of 1/2, I can use a power rule of derivative. That is, I have to bring this exponent in front of the variable and subtract 1 from the exponent. Then I'm getting 1/2 times x to the power of 1/2 -1. Let me continue. 1 over 2 times x to the power of, when I simplify this one, I'm getting -1 over 2. Okay, now to make this negative exponent as positive, what I have to do is I have to move this term to denominator. When I do so, I'm getting 1 over 2 times x to the power of positive 1/2. Then we get to 1 over 2 times. Whenever we have exponent 1/2, it can be written as square root. So then we get 1 over 2 times square root of x. Okay, now I got the derivative of square root of x. That is 1 over 2 times square root of x. So therefore, the derivative of square root of x over here is 1 over 2 times square root of x. And the derivative of this -2 is 0. Okay, now to get rid of the denominator dx over here, I multiply both sides of this equation by dx. So then this dx and dx will cancel. I'm getting du equals to 1 over 2 times square root of x times dx. Okay, now in this equation, I have to solve for dx so that I can plug in the stuff for dx over here in the given indefinite integral. So if I want to solve for dx in this integration, I have to get rid of this fraction 1 over 2 times square root of x. So for that, I have to multiply both sides of this equation by the denominator 2 times square root of x. Let me do it. So 2 times square root of x, I multiply on the left side over here. On the right side also, I multiply 2 times square root of x. Then the 2 times square root of x, 2 times square root of x will cancel out. I am getting 2 times square root of x times du equals to dx. Now I have solved for dx, but when I look at the stuff over here, I still have x over here. So there should be no x on the left side. So for that, what we have to do, we can solve for this square root of x in the equation over here in terms of x. If I solve for square root of x in this equation, what I have to do is I have to add 2 to both sides. When I do so, I'm getting u positive 2 equals to square root of x. Now we can replace the square root of x by this stuff u positive 2. So then I'm getting 2 times u positive 2 times du equals to dx. Okay, now I have solved for dx in terms of u. That is 2 times u positive 2 times du. Okay, now let me go to the given integration. So integral for this square root of x, we can plug in this u positive 2 divided by, for this square root of x -2, we can plug in u, and for this dx, we can plug in 2 times u positive 2 times du. Let me do it. 2 times u positive 2 times du. Okay, now we can multiply this one and this one. When I do so, I'm getting 2 times u positive 2 times u positive 2 will become u positive 2 the whole square over u times du. In this integration, this is a part that contains a variable. So this is what we are going to integrate, but this complete stuff is multiplied by the constant 2. In integration, whenever the function which is integrated is multiplied by some constant, the constant can be moved out of the integral. So then I'm getting 2 times integral u positive 2 the whole square over u times du. Okay, now let me erase this stuff. Now to integrate this function, first I have to get the expansion of the square of the binomial over here. For that, let me consider the algebraic identity, that is a positive b the whole square. So the expansion of the square of the binomial is a square positive 2ab positive b square. So the square of the binomial over here is exactly in this form. So instead of a we have u, instead of b we have 2. So to get this expansion we have to use the expression over here. So in this expression we have to plug in u for a and 2 for b. Okay, now let me continue over here. So 2 times integral. So for a square I have to write u square positive 2ab means 2 times for a we have to plug in u. For b we have to plug in 2 positive b square means we have to write 2 square all divided by u times du. So let me do further simplification. 2 times integral u square positive 2 times u is 2u. 2u times 2 is 4u positive. The evaluation of this 2 square is just 4 all divided by u times du. Okay, let me continue over here. 2 times integral. Okay, here u is a common denominator for all the 3 terms in the expression in numerator. Since it's a common denominator, it can be taken as a separate denominator for each term. Then I'm getting u square over u positive 4u over u positive 4 divided by u times du. So 2 times integral. When I divide u square by u, it is equal to just u, and this u will cancel. I'm just getting a positive 4, and here this 4 over u can be written as 4 times 1 over u times du. Okay, now we can integrate this expression. So we can integrate this u with respect to u using the power rule of integration. So that is u square over 2. So this is the result of the integration of the first term u. And here the second term is constant 4. So whenever I integrate a constant, the constant has to be multiplied by the variable with respect to which we do integration. Here we integrate over here with respect to the variable u. So this constant 4 has to be multiplied by the variable u. So the integration of this constant 4 is just 4u. And here there is a constant 4 multiplied by the variable. In integration, whenever there is a constant multiplied by the variable, always we have to keep the constant as it is, and we have to get integration of the variable alone. So the integration of 1 over u with respect to u is a natural logarithm of absolute value of u. Since it's an indefinite integral, always we have to add constant of integration in the result, that is positive c over here. And also we may have a question, why do we take absolute sign for u over here? Always the logarithm is defined only for the positive value of its argument. What is argument? So the value over here is the argument of this natural logarithm. Always it has to be positive. Even if u is negative, because of the absolute sign, always it is positive. For this purpose only we are taking absolute sign for u over here. Okay, now in my next step, I am going to distribute this 2 to all the terms inside the square bracket over here. When I distribute this 2 to this term u square over 2, this 2 will cancel out, then I am getting u square. So when I distribute this 2 to 4u, I am getting positive 8u. When I distribute this 2 to this one, I am getting positive 8 times natural logarithm of absolute value of u, positive c. Almost we got the result of the given indefinite integral, but here in this result we have u. So this is a variable taken by us. It has to be replaced by the original stuff, that is square root of x negative 2. So in this expression for each u, we have to plug in this square root of x negative 2. So here we don't have enough space, so let me erase the stuff and continue the process. This is the last step we have had in our previous work. Okay, so in this step we have to plug in the square root of x negative 2 for u over here, because we have assigned the new variable u for the denominator of the integrand. Okay, now let me plug in square root of x negative 2 for each u in this expression. So let me consider the first term over here. When I plug in, I am getting square root of x negative 2 the whole square, positive 8 times. For this u, I have to plug in square root of x negative 2, positive 8 times natural logarithm of absolute value of square root of x negative 2, positive c. Okay, now we can get the expansion of the square of the binomial over here using the algebraic identity, that is a minus b the whole square, which is equal to a square negative 2ab positive b square. So this is the expansion of the square of the binomial, that is a negative b the whole square. So the square of the binomial over here is exactly in this form. Instead of a we have square root of x, and instead of b we have 2. So in this expansion, what I have to do is I have to plug in square root of x for a and 2 for b to get the expansion of the square of the binomial over here. Okay, now let me continue. So for a square, I have to write square root of x a whole square. Negative 2ab means I have to write 2. For a, we have to plug in square root of x, and for b, we have to plug in 2. Positive b square means it's 2 square. Now I have to distribute this positive 8 to the square root of x and negative 2. When I do so, I am getting positive 8 times square root of x, and when I multiply this positive 8 and negative 2, I'm getting negative 16, positive 8 times the natural logarithm of absolute value of square root of x, negative 2, positive c. Okay, so here the square root and square will cancel out. I'm just getting x, and negative 2 times 2 is 4. 4 times square root of x is 4 square root of x, positive. The evaluation of this 2 square is 4, positive 8 times square root of x, negative 16, positive 8 times natural logarithm of square root of x, negative 2, positive c. Okay, now we can write the first term x as it is. We can combine this negative 4 times square root of x and positive 8 times square root of x, because both of them are like terms. Both the terms contain square root of x. When I combine them, I am getting positive 4 times square root of x. Now I can combine the two numbers, positive 4 and negative 16. When I combine them, I am getting negative 12. So at last I am writing this term, that is a positive 8 times a natural logarithm of absolute value of square root of x, negative 2, positive c. So this is the result of the given indefinite integral, that is square root of x over square root of x, negative 2 dx.